Let's get Facebook all set here. Do they keep the same areas? I think they expanded slightly. No, they kept pretty much same areas. Yep, there it is. Okay. Cool. Let's go live on YouTube. See if we can't get going. We're live on Facebook. Here we go. All right. We are live. I will give just a second to get some people to start joining in from here. But what's going on, everybody? Blaze from Windseeker. I know not very many people are live in the stream yet, and that is okay. They can always go back and rewatch. Right now, we are currently monitoring a very potent, possibly severe weather setup. The SPC has elected to stay at a level 3 out of 5 enhanced for now. Again, this is day 3, Monday. So we still have plenty of time for more forecast models to come out, for more guidance, more changes that could possibly happen. But they have elected to stay a level 3 out of 5 right now. I am fully expecting them to at least go moderate risk with this. This just has too good of a look to stay at an enhanced risk. That wouldn't do this justice. There are a couple things that could hold this back, and we will get to that as we get into the forecast models here. But like I said, as of right now, the SPC has chosen to stay at a level 3 out of 5 enhanced for now. We're expecting possibly tomorrow they could upgrade this to a moderate risk, and I would put it right here along the Mississippi River corridor, around like the St. Louis metro area, going down into southern Illinois, southeast Missouri, possibly even dabbling into western Kentucky. But we'll see. I definitely think south of I-70 is going to be the most potent region for severe weather. So that's where we're at right now. I think tomorrow they go moderate, just based on what we're looking at. And we'll show you everything we're looking at here, because this is spicy. You only get a look like what we're seeing once every year, maybe every 2 years. So we'll show you kind of the factors right now. This is machine learning. So you're kind of looking, this is from Colorado State University. They put out a machine learning model. Kind of shows the highest probabilities for stuff as it goes, which it's staying north. The problem I see with the northern mode of this is the fact that that's going to be the highest probability of going linear. And with it going linear, your tornadoes, there's still a very high probability of tornadoes happening within that area. They just won't be as significant, so to speak, as compared to down here, where we're kind of more expecting kind of more of a supercell threat more than anything. So it's coming out pretty strong with hail as well. Near 50% chance for hail right there in that St. Louis corridor. And then the tornado probabilities, it is staying down almost 40%. So it is actually pretty close to popping up a purple box on here. So machine learning is kind of picking up on a potentially big day as well come Monday. So let's get into some graphic or some forecast guidance. So I've already kind of peeked through a little bit, so I've already got some stuff loaded up on here. We are going to switch over. We're going to first look at the driving mechanism that catches everybody's attention first and foremost for severe weather. So let's go to the national scale and let's look at this trough. So right now we're looking at a 500 millibar trough that's supposed to eject. So Monday morning, it showed, which that 500 millibar trough, for those who don't know, that is an upper level low pressure system. So right now it's got an open low on the trough centered right around Nebraska Monday morning at about 7 a.m., right about sunrise, 7 a.m. Illinois time, 8 a.m. Ohio Valley time for those of us that are on real time. So, and you can see as it goes, it advances through, and by the peak of this event, really, this trough is pretty negatively oriented. And this is looking at the GFS, but we have a negatively oriented trough, decent jet streak, so very fast moving winds within that trough. I mean, we're looking almost 200 knots of flow within that trough, and then it ejects right over the Midwest into the Ohio Valley, the lower Ohio Valley. So that's what's driving this severe weather threat partially, or that's a key ingredient to it, I should say. As we go in throughout the day, and we're gonna look at several models as well. You can see the low level jet. This is about a kilometer above our heads. That thing is screaming. Like, I mean, we're looking 70 knots almost over here. We're sitting at 60 on here. You've got some pops going into Indiana, getting over 70, possibly approaching the 80s in some spots. So you've got a pretty decent low-level jet up ahead, and that's huge to drive your moisture return, to drive your spinning in the atmosphere. That is a huge ingredient when it comes to tornadoes, so to speak. Let's zoom back in, if it'll work with me. Let's zoom back in, and let's drop down into more of our surface observations as we go. So temperatures throughout the day, closer to the heat of the event, and you can tell where it's going on because it cools off pretty quickly. But huge warm sector. I mean, we've got temperatures in the 80s right around the time this event's supposed to be starting and ongoing. So you've got temperatures in the upper 70s, getting into the 80s, and then dew points. This is a huge one right here. You've got dew points up in the 70s. So it's a huge amount of humidity in the atmosphere. So this is going to drive that instability, which is what these storms need to fuel off of. Hugely humid. I mean, it's going to be super muggy outside. 80s over 70s is quite insane. And a lot of notable severe weather events have happened with the same thermodynamic environments at hand in terms of 80s temperatures, 70s dew points. One I can think of off the top of my head was May 20th, 2013. I'm not saying that's the event we're going to have. I'm just saying that's one to compare to whenever it comes to looking at thermodynamic setups like this. Normally you see mid 70s over mid 60s. So for this to be going up, and if I were to pull a hodograph just real quick to kind of show you what I mean, if you're able to see these green lines right here, this is your mixing ratio. And the further up your dew point goes on these, so 1 degree difference back here, closer to your 10 degrees Celsius range, is not as, substantial as a 1 degree difference up here close to, say, your 20 to 30 range. Every time you go up, your mixing ratio pretty much doubles. So for a dew point being back here in the 60s is a lot different than the dew point being up here in the 70s in terms of your mixing ratio and coming into causing that instability and causing that wild environment. And while we have a hodograph pulled, I want you to look at this low-level shear, huge curvature on these hodographs. This one is kind of funky going in the end. This doesn't look like the ones that I was pulling on this exact same model just a few minutes ago when I was kind of taking a sneak peek beforehand. But it's also noted, 40 knots. We've also had some in the 30s for storm motions as well. So you're going to have some slower moving storms with this. Something else to note, your instability in the lowest 3 kilometers, 190. Keep in mind, 50 is enough to support tornadic storms. So we're almost 4 times what you need to support tornadic storms. So that is not a problem at all. Instability overall, that's this white dashed line. The further away from the red line it gets, the more more unstable it is. Right now in this spot, it's showing a little over 3,200 surface-based instability. There's some spots in here that have been showing over 4,000 on some models. I've got 3 4 models, I think, pulled up. Yeah, I've got 4 models pulled up that I'm going to show you guys off of. Pretty much the same things to kind of show the comparisons here. So, but I don't want to get too far ahead of myself yet. Now we'll look for a surface low as well. So it's showing a surface low centered over kind of eastern Iowa up here. And usually about 200 miles south and east of your surface low is where you're going to expect the greatest chances for your significant severe weather to happen. So that'll put it somewhere over in here around the St. Louis. Now keep in mind, this is 200 miles as a crow flies, not driving. So 200 miles as a crow flies would put it somewhere around the St. Louis area, which is what our target area is for Monday. Yes, we will be chasing, we will be streaming. Spoiler alert. This is too good to pass up on. So, but that would put that somewhere around the St. Louis area, 200 miles as a crow flies, 2 to 250. That's kind of your sweet spot from the surface low. So you do have that. Surface level winds, you have south to a little bit of southeasterly winds. And that is super important because right here where I've got my cursor going down, that is the Mississippi River as obviously. And what that is a valley. And what that valley does is as you have this wind screaming through here, it's taking moisture from the Gulf and surging it through like a funnel and pushing it and driving it up into our area. So that is super important in terms of inflowing this warm, unstable air into the environment for the severe weather. So let's go in. One more thing before we get into the nuts and bolts here. Let's look at our most unstable cape. So let's go into our instability for the environment. You can see huge instability levels, over 3,000, getting up into the 4,000s for instability. That is insane. Usually 1,000 is what it would take to support severe weather, about 2,000 to really drive up a heavy tornado risk. So for us to be seeing 4,000, that's significant. That's just another player into why we're saying this could be a potential significant event in terms of all this. So let's look at a hodograph map to kind of show you a better idea of our wind profile. So you can see all across the region through here, a huge low-level instability. When you have that clockwise curvature, that is what you want to see. You want to see good clockwise curvature, and you really want to see this go out and away. And that's pretty much what it's doing. So we've got plenty of low-level instability, low-level wind shear for this stuff to work with to really drive that spin in the atmosphere. So let's go into what you all want to see. I'm going to back up to the start of the morning here and kind of show the progression of storms on the GFS. Again, I've got 4 to show you. So something that concerns me a little bit is the fact that it's got some showers on here, but the models have been all over the place on whether we will or won't have showers. This is one of the things that could alter how this event goes. There's 3 things off the top of my head that I think could really turn this off and make it not as what we're forecasting to be. And this is one of them, especially with this happening right there, 12Z. So that's 7 a.m. Central Time, 8 a.m. our time. So the sun's already coming up. So the showers are going to have lingering cloud cover. And that's going to be a problem in terms of allowing the sun to come in and heat the environment up. So if those happen, we're not really going to see as much of a severe weather threat. So moving on, you can see the GFS, something that I noted here, how thin and broken this is coming down. These globals, which is the first 2 I'm going to show you, they don't do good at showing your storm mode. All they can really show is that, there's probably going to be precipitation in the area. So this is showing right around 4 o'clock Central, 5 o'clock Eastern, storms are chugging through Illinois. And with this being broken, this could suggest a thin line or it could suggest supercells going through the area. So we'll pull another sounding just to kind of give you all an idea here. So again, huge low-level shear. That's important to note. 24 knots on your right mover. So these are going to be slow-moving storms, and it's going to be moving northeast. So this is pretty stereotypical. 82 degrees over 69, so pretty much 80 over 70s like we were looking at. Your low LCLs, big instability going through here. This is showing surface-based CAPE almost 4,000 on here. So huge SRH, which your helicity is the spin or the energy used to spin the atmosphere. So just insane values here. 150 on any of these is what you would want to look at. And I mean, you're looking up towards 3 kilometers up, surface to 3 kilometers in that range, which is your lowest level, what we try to look at in terms of tornadic storms, 325. That is insane. So there is absolutely a high ceiling going on here. This has the potential to do some good things depending on what goes on. So, and then moving on, going into the Ohio Valley, where most of my followers are from, you can see a lot of this, it starts to congeal together, turns into a line, which then poses your damaging wind risk as it pushes through the Ohio Valley and into the Louisville area. Around sundown, probably a little bit after sunset, going into the overnight hours. That's when I would expect it coming in towards like the Louisville area, the I-65 corridor, in that range. So, and you can see it just progresses on. That is the GFS. Again, when we forecast this stuff, we don't look at just one model. So let's keep going. Let's look at the Euro model, which again, I've already peaked at these, so it's kind of already set to where I was peaking earlier. So let's go back to early in the morning. Let me put on the national scale so that you can see an overall picture here. And let's change to your 500 millibar. And let's look at the same thing. So upper level wind. So the Euro agrees with the same thing. You have an upper level low, except this time it drives that low just a little bit north, but the streak and the actual like part of the trough you would focus on is still there. It's still somewhat negatively tilted. Not as tilted as some of the other models are showing, but you can still see as it goes. You can watch this trough swing as it goes. So you can see it through there. Then you advance and it swings a little farther, and you advance and it swings a little farther. And that's something to note when we go into here, because that also drives our severe weather, because that also helps force this wind even quicker through here, to try to put it in layman's terms. So there's a lot to it as to why it is what it is. But you can see through here our low-level jet. The Euro model is a lot more conservative on your low-level winds. And I try to show you all these models so you can try to see what we go as, or what we use to figure out what's going on, and the inconsistencies that you show. I mean, you see just between two models how it was showing all your 50s and 60s going all the way down, almost all the way south into Illinois. And this is just showing a little pop of it up here. So that shows the inconsistencies and why sometimes it is so difficult to truly hone in on what's actually going to happen, because these just do not like to cooperate. They don't like to agree with each other. It's like siblings, honestly. That's the great comparison for them, is comparing them to siblings. They don't like to agree. So they like to argue, they like to contradict, and it just makes it harder on us trying to forecast this that's going on. So moving on, let's see what the Euro showing with your temperatures. So we'll go back in, we'll move it up. The Euro is in agreement in terms of your temperatures, showing low 70s, upper 80s going into the Illinois, Ohio Valley area. And then your dew points, the Euro is a little bit shy on moisture. So the Euro is keeping it down towards the mid to upper 60s rather than dabbling into the 70s in the hot zone, so to speak. So that does kind of alter a little bit what we could be looking at, because you're going to have a bigger spread in terms of your temperature and dew point. It's also a lot harder to pick out a definitive surface low here to run off of. Overall, it's going to be up here more towards northern Iowa. So we're going to be a lot, in the Euro scenario, it's a lot more separated from that surface low, which could be a problem. Now, you can see in here, it's got a couple closed lows popping up in here, which that will drive up some severe weather potentials, some local closed lows randomly, but the overall low is way up here in northern Iowa. So we're a lot more separated in the area that we're watching in the Euro scenario. Let's go into some instability values here on the Euro. So we'll go to most unstable. That seems to be one of the better ones to look at, so you're not trying to figure it out. So the Euro is a lot more conservative as well with instability, mainly because there's a bigger temperature dew point spread between these. So that's going to lower the amount of instability available. I mean, you still got some values going up into the 3000s, upper twos into the 3000s across the area. So don't get me wrong, this is still a very severe environment to be dealing with. Just it's not as high up as this the GFS is showing. Looking at our hodograph maps before we go and pull some soundings here, the wind shear environment's still good. I mean, you look up here, this hodograph just around the East St. Louis area, maybe a little north of there. Look at this huge curvature that it's got in here. That's going to drive that severe weather threat majorly. Same as you go down towards the Ozarks as well. Just a huge curvature of your low levels. So the threat is still there on the Euro scenario, even if it's more conservative. And you'll see as we kick into looking at our storm mode. So you can see the Euro already has storms that start up early in the morning and just push on through, but it doesn't show the southern morning convection. It shows the northern convection more in central Illinois. And this is well after the sun has risen, when we really don't need any of this to be in the area. So that would be a problem. And just again, it just goes to show the inconsistencies between these, because the GFS had... I'm going to crash out. The GFS had convection, your morning showers and storms down here, and earlier in the day, while the Euro was showing it up here. So again, that's why we say it's hard to talk about this stuff so far out. Then you start to look going into the day or towards the afternoon when we're expecting these storms to be taken off. You can see dots popping up over here. So the Euro is suggesting this stuff starts off as supercells with a northern linear mode, and then they all pretty much congeal going up into a line as it goes. And then it's consistent with timing in terms of where these storms go. So again, with starting to come into the Louisville area, the I-65 corridor after sunset, going into the overnight hours, and it pushes through and then clears out before morning. So that is the Euro model. Let's go into one of our convective allowing models. We use these a lot when we get close to the event, but there's really only two that are in range. There is a third in range, but I would rather die than try to trust anything that model says. So those of you who know me know exactly which model I'm talking about. So it's in range of it, but I'm not looking at it. I looked at it earlier, but I didn't believe it because it is way off in left field on what it's showing. So let's come up here. Let me back up a little bit and go into this a little bit. I know I've not updated my card in the website yet to my new card. I've got 2 cards ago still in here for my annual payment. But anyway, looking at this, we'll go back into the morning. And something else to note, these convective allowing models, they run hour by hour. So the 2 I showed you before, the global models, they show every 3 hours. So it went from 5 Eastern to 8 Eastern to 11 Eastern to 2 a.m. Eastern. These, they go hour by hour. So this is 8 a.m. Eastern, 7 Central. The next one, there's 9 Eastern, 8 Central. So, so that's something to note. So we can actually go a little more like in depth with the convective allowing models. Now this one is the RRFS. This is one that it's still experimental. They're testing it. It's been released to where the public can look at it, but it's still experimental. So there are going to be some flukes that come out with this one. And this one in particular tends to be quite aggressive. In terms of storm mode and placement, it has been on the bubble or like on the dot the past probably year or two. It's been very like hitting the nail on the head with storm mode and placement. It's just aggressive with how it displays your storms, as well as the environment at hand. Sometimes it can get overly aggressive, but sometimes it doesn't. I'm really waiting for the HRRR to come into range, which it will tomorrow evening. Tomorrow evening, I'll be able to use the HRRR to look. Well, actually, hour 48 right here on the 12Z. So actually, tonight, I'll be able to open up the HRRR and look forward at least up until 8 p.m. Eastern, 7 Central, at least to that time frame. So once that comes available, that's the one I trust the most. And that's the one I'm going to look at when it comes to this. But let's break down the RRFS here. Let me go back to the national. Let's show you the 500 millibars. So we can show you the translation of it, how it looks, what it's doing. So let's go back to our 500. So this one seems to be a lot more. Again, I told you it's aggressive. This one's already getting aggressive with it. It's showing a closed low on your 500 millibar level. Already starting to take on a bit of that negative tilt. And you can see as we go through, it translates pretty well as we go through Monday. So here's about 2 o'clock Central Time. Yeah, 2 o'clock Eastern, 1 o'clock Central right here. You can already see an aggressive negative tilt with that jet streak going through, and it's still translating well. So the translation is what I mean is it's tilt. So you see how it's tilted, so it's swinging. So when we started off the day, it looked like this, and then we're finishing and it's like that. So possibly. Okay, it's not letting me do the draw tool. That's fine. But you can see where it swings out. And by the time you really have storms rocking and rolling, you've got a heavy jet streak feeling these. So let's go into our 850. So this is the time that I was showing you with all the others. This one is kind of more in agreement with the Euro in terms of the low-level jet. So you've got 50s to 60s coming up over here, more in your 40s, getting close to your 50s down here. So this one is more in agreement with the Euro, but in terms of storm placement and mode, you can start to get a different idea out of this. So let's zoom back in, and then let's go down to the juiciness here. I'm going to back up a little bit, which I've already spoiled it for y'all, but we'll go back into it. So let's look at this. So the difference in this, you're going to see some little black ovals or black boxes coming out of the back of these. That's just showing potential updraft tracks with these storms. So it does cluster it up a little bit, but it should show you a little bit. So you can already see well into the afternoon up in Missouri, it's got supercells firing off. And then as we progress through the day, you can see, so we're sitting, there's 5 Eastern, 4 Central. There's 6 Eastern, 5 Central. You can see it's got supercells firing off. As it goes up, it's going to congeal into a line. But something I'd like to note is the supercells firing down here, west of St. Louis. This is the stuff that I'm going to watch. That's the stuff I'm going to be on the lookout for. And looking at your proximity soundings or estimated soundings, again, slower moving storms. I mean, this is 40 knots. So looking at probably 30 to 35 mile an hour move or motion. You looking at your curvature, your hodograph, still a good curvature at the low levels, 104, so more than twice what you need to support tornadic activity. So this is definitely getting to look good. As they approach the Mississippi River, we're going to go down a little bit and watch these storms as they're firing to show that throughout the day it's progressing more. This sounding is one that I really wanted to show you guys in terms of the wind shear. You can see where it just curves and it shoots off and goes away. This is significant in terms of wind shear. There's a significant amount of wind shear, a significant amount of energy available from the wind for these. But something else to note, your downdraft cape, almost 1,500 is what it's showing on your downdraft cape. Normal severe weather events, we're sitting at like 700 or 800. So we are twice what we see in a normal event. So that's where I mentioned, on our graphic yesterday, wind gust up to and possibly beyond hurricane force it's on the table. It's absolutely possible. This is just an insane amount of downdraft cape available, which cape is convective available potential energy. That is the storm energy. Those of you in the Louisville area that have watched Mark Weinberg when he talks about storm fuel, that's storm fuel. The cape that we talk about. This one's got about 3,000 cape surface based coming through here. That's how far separated this white line gets from your red line. So it is significant. But I love how it shows your supercells firing off, and then right here it's starting to show everything congealing more into a linear mode. Again, I'm going to wait for the HRRR, especially as we get into tomorrow, to kind of figure out what we're doing with this. Still showing a great amount of wind shear in the low levels. And then you can see as it moves off, here's something else to note, these little blips that pop up ahead of it as it moves on. Here's something else to note. Once the RRFS, we call it the RARA or the Rufus, once it gets beyond 60 hours in the future, it changes to 3-hour increments. So that's why there's such a huge jump to right here. But something else to note, still has supercell activity going on down here after dark, going into the night, and has some blips popping up as he gets towards the confluence of the Wabash and the Ohio River, towards the Evansville area, Mount Vernon, Henderson, Kentucky, Owensboro out here. So it's still showing these renegade cells popping up, and that is a little bit of a concern because that tornado potential is still going to be there. Even in the line, you're going to have the potential for plenty of embedded tornadoes, QLCS tornadoes, and they're weaker tornadoes, which you can see with all these different updraft tracks. Could potentially be tornadic spots coming up in these storms. But the stuff that stays isolated on its own, that is where you're going to get your strongest tornado potential in terms of your strength of your tornadoes. The RRFS is a little bit lagged behind compared to the global models. The global models by 3Z, which is 11 p.m. Eastern, had the line coming more out this way. So it had getting it closer to the Breckinridge County, Kentucky area, Perry County, Indiana with Tell City, then going up the Indiana 37 corridor, going up towards like your Martinsville and Paoli and Bloomington and that area. So it had them more out here. This still has it out into Illinois, crossing over into Indiana. And then going into 6Z, which is 2 a.m. Eastern, finally has it crossing through the Louisville area. So this one's very reserved. Now I'm going to show you a model that I don't do much looking at. I really just use it for consistency. So I'm not going to go too deep into this model. I really just want to show you this right here that it's showing. So this is also showing supercells on the southern mode with a line on the northern mode. So that's pretty much just what I wanted to show you. And with these isolated cells, the environment we have in hand, each one of these cells could have a tornado ongoing at the time. So, I mean, this right here is already showing 5 cells capable of producing tornadoes at the same time. So that should show just how dangerous this setup could be if it goes to plan. Again, there's some things that could not go to plan. Those things being morning showers. If we have morning showers come through, that might shoot this down the drain very quickly. Because the cloud cover and the inability for the atmosphere to get up to that just potent look that it's been giving us. The other stuff would be the cap not breaking. So if the cap doesn't break, that's going to present a problem. But I don't think that's going to be an issue. We're going to have enough forcing in this atmosphere that something's going to be able to break through that cap. That cap should be able to erode pretty quick. So I'm not very concerned about the cap erosion at all. And then the third thing I can think of that shoots this down the drain is instead of having these supercells, it all just turns into a line really quickly. That'll drive up that damaging wind threat through the roof. But that overall significant tornado, that large, strong, long track tornado threat is going to plummet quickly if this stuff goes into a line too quick. So there still are some fail modes that it could happen. There are some things that could fail this forecast, but we don't know yet. We're still waiting on further guidance. But the fact that this stuff has been consistent for the greater part of a week, that's saying something. So that's why everybody's really been trying to go on about this setup here. So let's go into some, I I know. Let's go into some composites that are put together, a lot of it using machine learning analogs. So this is StormNet. Why did it? Are you serious? Okay. So this is StormNet. This is showing your overall tornado risk, and it's really highlighting everything south of Bloomington and being in a 50% or greater in terms of this. Now, this, I like to note it because this is usually pretty accurate. This has nailed the past several events that have happened in terms of like your placement of your greatest tornado risk. This thing has been on the dot. Now, obviously, everything is doomed to make a mistake. So that's why I'm not just sitting here, being, oh my God, this area. But this stands out. The fact that it's showing up close to 75% in some spots. So moving on to the NSSL, this is a composite showing your total severe weather probabilities. And the hatching shows the potential for significant severe weather. So this is showing up in your 45% range. Close to your 45% range, with hatching showing the potential for significant severe, all the way from Texas up through Illinois and then into Western Kentucky. And it's been showing this also for quite a while. I mean, you can see how far in the future we can go. I can go all the way up a week and a half in advance. So this has been showing this for quite a while, ever since it really came into range. So this is not the SPC Convective Outlooks. This is rather a research center that uses the stuff at hand, does some algorithms, and says, hey, these parameters at play would best fit this probability in these spots. So this right here is saying that a moderate risk is, according to the computers, it fits that fits the best probability to go out there. And it's centered. You got St. Louis centered in there, and this whole area drives around it. And then it also gives more of a hazards breakdown. I don't know how much of this y'all are able to see, but in terms of your hazards, looking at it, 45% hail with hatching, so showing significant hail, so greater than 2 inches in diameter. So you can see there's a huge area that could possibly see greater than 2-inch hail. Your wind outlook, again, the hatching is significant. So for wind, it is above 75 miles an hour, or above hurricane force, so 74 knots. Trying to remember what all that translates to. I'm looking at my hurricane thing that I have up there. So yeah, I think it's greater than 74 knots or something. But yeah, anyway, yeah, it's showing your potential for significant wind, nonetheless. And then significant tornadoes, another big area outlining the potential for significant tornadoes, with that hatching being for EF2+, because this hasn't updated to the new SIG forecast guidance that they've come out with, the new SIG intensity group, the conditional intensity group that they've come out with starting in March. So this hasn't caught up with it yet, and that's fine. So that's what we've got for our weather coming up. I wanted to outline this, highlight this, to show really what we're looking at, what all the hype is about, and then to show the inconsistencies in some of the models that are still showing. And even with those inconsistencies, I think we are confident in saying that this has potential to do some wild stuff. So hopefully people are a little more versed on what's coming in Monday, what could happen. And we are going to be in the field. We are going to post updates. Again, I am expecting this to go moderate risk all the way. I don't see any way that this doesn't go moderate. Honestly, the writing's there. Everything's sitting there. So I think we definitely see a moderate risk. Definitely tornado driven. Definitely hail driven. This stuff's too big. I see tornado and hail at least for moderate, but I think wind could also jump up into what could qualify for moderate. So I like to thank everybody that joined in, and then watch as we move on, getting closer to this event for our updates. And again, we are going to be chasing this for sure. You get an environment like this once every year or two, so there's no way we pass up on it. We've got to go chase. So we will see you all out in the field. We will be live streaming Monday. And hopefully we can catch something to show you guys. And hopefully, our stream can be used to provide awareness to what's coming at people. Hopefully, even if one person is able to use our stream and say, hey, this helped me seek shelter before this hits, that's good. That's what we're doing it for. That's why we're out there. So I don't care if it's one person or 20 people. It's just as long as our stream makes a difference in somebody's severe weather preparedness and taking action. So thank you guys for joining in. I will see you guys probably tomorrow. I won't be doing a live tomorrow, but I will be posting updates. So we will see you guys on Monday when we are live streaming our storm chase. So we will see you then.